Okay, hello guys, welcome to recitation number 4. Here we'll be dealing with the inclined plane. Before we start solving the problem, I would like to explain briefly on the forces on an inclined plane for you guys to understand really quick, okay? So if I have this book as an inclined plane like this, and I put this marker here, I see the marker rolls down. You see, the marker rolls down. I didn't apply any force. The marker rolls down by itself. So there is some force pulling the marker down. Think about that force. Some of you might say it's gravity, but gravity goes straight down. So that's half of the answer. Partially correct. I'll tell you what is going on. I call that force the spiritual force. Now let's do some spiritual physics right here. So if I have a force on an inclined plane, an object on an inclined plane like this, where does the spiritual force comes from? It is not directly the weight, but it comes somehow from the weight. So the first thing you should know for an inclined plane is your x-axis is parallel to the plane. Your x-axis is not like this. Your x-axis is now like this. So this is x. And your y is perpendicular to the plane. This is y. Is that okay? So your normal force is along the y. I call Fn, perpendicular to the box. Your x-axis is like that. Your weight is straight down, mg. So your weight, since I've chosen my x to be like this and my y to be like that, my weight becomes a force in between the x and y axis. So it becomes a force. I should find the component. If this is theta, that is also theta. So the weight now has a component along the y and a component along the x. So the component along the y is this side, mg cosine theta. The component along the x is mg sine theta. This is what I call the spiritual force. Mg sine theta is the x component of the weight. That is what always tries to bring every object on an inclined plane down. So whenever an object is on an inclined plane, mg sine theta always acts. But nobody will show it to you. You should know that there is always an mg sine theta acting down, okay? And now we can solve this problem, okay? We can solve this problem. So let's look at the problem. It says, on the inclined plane shown above, a block of weight 10 Newton slides down the plane. Identify each of the vector forces. So C is sliding down. Is that okay? It's sliding down. So C is going to be friction in the opposite direction. D is weight and B is normal force. Normal force B, friction C, weight D. If the coefficient of kinetic friction between the 10 Newton box and the plane is 0.4, so they are giving us coefficient of friction mu is frictional force over normal force, okay? So it'll be 0.4. Find the magnitude of the frictional force. Okay, how do we get frictional force? So it's sliding down. Is that okay? So when you are sliding down, we are having some acceleration because we are asked to find acceleration. So it means, first of all, acceleration is along the x-axis alone. The y-axis is still in equilibrium. So my normal force will balance the y component of the weight, mg cosine theta. So my normal force is just mg cosine theta. So that is the weight, mg 10 cosine 30 degrees. 8.66 newtons or 8.7 newtons. That's my normal force. So what is my friction? Friction is mu times normal force. So friction is mu times normal force. Mu is 0.4 times 8.7. So 0.4 times 8.7, that will just give us 3.5 newtons. So that is the frictional force. Okay. What is the normal force? I already got the normal force to be 8.7. Acceleration down the plane. I'm accelerating down the plane. Spiritual force is down. Spiritual force minus frictional force equals MA. That's the net force. This minus that is my net force. So mg sine theta minus frictional force. I know my frictional force is 3.5 equals, let me put it there, minus frictional force equals MA. This is what I'm solving. So mg is the weight, which is given to me 10 newtons. So 10 sine 30 degrees minus frictional force minus 3.5 equals the mass. I have to calculate the mass. Is the weight divided by 9.8. 10 divided by 9.8 times A. So how do I solve for A now? 10 sine 30 is 10 times 0.5, which is 5, minus 3.5 equals 10 divided by 9.8 will give us, I think, 1.18, right? So let's do that. 10 divided by 9.8, am I correct? Is it 9.1? Oh, 1.02. 1.02. So 5 minus 3.5, that'll give us 1.5 equals 1.02A. So A is 1.5 divided by 1.02, which is just 1.5 meters per second squared. And that's how you get that. Okay? So the first thing to understand is the normal force is always equals mg cosine theta if there is no acceleration on the y-axis. And your mg sine theta will either keep this guy in equilibrium or accelerate it down, or you are taking this guy up. You have to always consider mg sine theta. In this case, it's accelerating down, so mg sine theta is greater than friction, so friction is this way. So mg sine theta minus friction will be my net force equals ma, and that solves the last part of the problem. Thank you guys, and see you guys next week. Have a good one.